Hello. So today what we are working with is solving equations with variables on both sides. Now, we're going to start with what I'd like to call the normal ones, and we'll talk later about kind of the weird situations that pop up. But let's go through solving these and we'll get some normal answers. First step with solving an equation is, first off, just figure out what you're looking for. If I'm doing number 1 here, what I want to do is I want an answer that is x equals a single number. So this is what I'm looking for, right? But there's a problem. Usually when we've been solving, we have had a single x, or if we haven't had a single x, it's been two x's on the same side, so I've been able to combine them and simplify them. So here, if I'm looking at what is different about this one as opposed to the previous problems, is I have this two-sided x. So I'm going to have to fix that. I'm going to have to move something from one side to another. And in order to move something from one side of the equation to the other, I can add its opposite to both sides. Now be careful when you're doing this. Remember that if you are moving something or canceling it out, it has to be done to both sides. And also remember that you are combining like terms. So this 2x, when I add it to the left side of the equation, has to be added to the 7x, not to the 19. So that's going to give me 9x plus 19. And on this side, I'm left with just 55. Now this looks like the problems that we did before. So I can go ahead and solve it like we did before, using the reverse order of operations, starting by undoing things from the bottom up. So here I'm going to undo my addition and subtraction first, getting rid of 19 by adding the opposite, since 19 was added. That's going to give me, well, the 19s cancel, and I'm left with 9x is equal to 36. Here, I want to get x by itself. I want that x equals. So I'm going to get rid of the multiplication by 9 by dividing by 9, the inverse operation. And that's going to give me x is equal to 4. Now, just like before, you have to check your answer. Now, unlike before, your checking answers will look a little bit different because this time, notice that I have a couple x's, so I'm going to be substituting in my x value more than once. Now, I know it's tempting to substitute in over here, but if you made a mistake when you move that 2x over, substituting into here will not catch that mistake. So you always should go back to the original problem when you're checking your answer. So 7 times x plus 19 should be equal to a negative 2 times x plus 55. And here our proposed answer is that x is equal to 4. So I'll write 4 into both sides, and I can check my answer. Well, negative 2 times 4 is negative 8. And negative 8 plus 55 is going to give us 47. And on here, 7 times 4 is 28. 28 plus 19 is 47. Since I know that 47 is equal to 47, I know I must have done it right, because otherwise these things would not be balanced. So I'm good to go. Now, if all of this makes sense to you, that is great, and you can move on to the homework. However, I recommend you watch one more example with number 4. For number 4, I'm going to follow the same process that I did before. Remember, I want an answer like y equals something. Before I got x equals 4, this time let's see what y equals 2. Well, here there's a slight problem, because just like before, I have too many y's, only this time I have 3 different y's. That's a lot of y's to deal with. So what I'm going to try to do is, instead of trying to tackle everything at once, I'm just going to combine what I can on one side, make it look simpler. And I know that I can combine any variables that are the same with the same exponent. So that means I can combine the 5y and the 6y to get 5y plus 6y, or 11y. And I still have this minus 2 that can't be combined because it doesn't have a y. It's a different term. On the other side, well, y and 10 cannot be combined, so they are going to stay the same. Now what I want to do is I want to get these y's together, but they're on opposite sides. That means I'm going to have to move one of them. Now, good question to ask yourself is which one is going to be easier to move? And the answer is it's always going to be easier to move the smaller one. So for instance, I'll want to subtract this y over here. Just like on the other problem, I added the 2x because a negative 2x is smaller than 7x. You'll always want to move the smaller one just because it makes it easier to work with. If you move the larger one, you're going to be dealing with negative numbers for sure. Whereas usually if you're moving the smaller one, you can get towards positive numbers or at least some smaller numbers to work with. However, if you move the wrong one, it does not mean that you can't solve the problem. In fact, you'll still get the right answer even by moving the 11y instead of this y. It's just going to look a little bit different in your work. All right, so now that we have that settled, I have 10y minus 2 is equal to 10. And that means that I can solve by adding 2 to both sides, undoing my order of operations, to give myself 10y is equal to 12. And when I divide by 10, I get y is equal to 12 over 10, or 6 fifths, or 1 1/5, or, if you want the decimal, 1.2. Once more, I have to check my answer. Now, this is going to be a big check. That's okay. Again, I am going to write out my problem, leaving those blanks for y, and watching my signs very carefully. I'm going to see what both of them equal and double check that I got the right answer. So these two things should be equal. Here I'm substituting in my 1.2 into all of those spots where y was, because y is the same as 1.2 if I did this right. And when you type that into your calculator, you should be able to go in one fell swoop as long as you're careful with your parentheses and negatives. So I have 5 times 1.2 minus 2 plus 6 times 1.2. And I like to use the parentheses just to make sure nothing went wrong. That gives me an answer of 11.2, and I'll record that here. Now let's do the second side. 1.2 plus 10, oh, we do not need a calculator for that, right? That just gives us 11.2. That means that we have 11.2 on both sides. Therefore, our answer must be correct, and I can write in my final answer. For your homework tonight, please complete 2, 5, 3, and 6. So go ahead and complete these. I hope that you have a wonderful day.